Hi, this is Mr. Huff, and let's take a look at the last portion of the final presentation that you will need until we get to the reflective portion. This is going to include a lot of things that we haven't done yet. So up until this point, you should just be kind of taking stuff you've already done and dropping it in, polishing it up, making it look good, thinking about your presentation. But now we're getting into things that we haven't really touched on yet. So first thing is, let's go through what you're going to put in this section. You're going to have your materials list. You're going to have a build procedure, safety concerns, tool selection, your timeline of your build, the document of the build process, and then your testing plans. There should be 5 of those. Testing results, there should be 5 of those. Your conclusions, and then thank yous and questions. So let's take a look at an example. This is an example of a materials list. So you're looking for cost and quantity. That's the focus, and then how much overall. So in this one, I have the vendor listed here, and the materials you're going to need listed here, and then the quantity of each material, the cost of each material, and then the total. We also stated that we were going to use reclaimed materials as much as possible. So you can see the stuff that we reclaimed, and you can see that while our total cost here projected if you were building from scratch would be about $150, we were at $45 out of pocket at the end of our build. But I also want to point out this was done hastily in 2 weeks, and we didn't finish our prototype. It wasn't rainworthy yet, but it did work. So procedure of build, this is just a kind of a high level step by step what you're going to do to, and the order that you're going to follow to build it. I would probably expect more detail on yours. Again, we were throwing this together very quickly because what you've done in a year we did in 2 weeks. But you can kind of look at this as an example. You may want to throw some more detail in there. Okay. I have some issues, some things with safety concerns for you guys. The reason I've had you doing those safety posters, you need to talk about the different tools you use and how they can cause injury and some things you should do to make sure you're safe. So in our presentation, that's what we talked about, how using this kind of saw, you needed to wear safety glasses and make sure your fingers and all that good stuff were out of the way. So we kind of talked about some general safety here, but you will have some specific information about specific tools that you use for your build. Tool selection, you need to list everything you would need to build your prototype. Don't leave anything out. So just list it all. Some images of those items would be nice as well. Timeline of the build, this is where you're going to break down about how much time it would take to actually build one of these. So think about how many minutes you spent on each task. This is where having that great documentation of your photos that you took during your build procedure, having that put together and just estimating these times. So you should end up with a pretty reasonable assessment of how long it took to build. And we ended up with about almost 6 hours to build our prototype, starting from raw materials until first test. Okay. Timeline of the build. So this is just kind of some documentation. Remember, if you put pictures in a presentation, the best thing to do is add some captions so that people know what they're looking at. And I'm looking at my examples I've been showing you, and I did not do that all the way through. So pay attention to that. But you can kind of go from your build process here, and you should have basically those steps in the right order. If you wanted to do this as a timeline, that would be fine too. But for us, we were just going left to right, working through the build here. And just put as many pages as you need to talk about your build. What I would suggest during presentations, talk about places where you deviated from your plan. Like right here, we have a deviation from our plan, and that would be a good thing to talk about. So we could also talk about challenges. For instance, this auger printed with a lot of support material, and it took hours to clean that up and get it to work. And then we figured out that it didn't fit into the part that we needed. So we had to actually sand the whole thing down. So that took another hour or so to make that. And it was because we designed it with the tolerances much too tight for the 3D print. So anyway, focus on some of the challenges and changes that you made to make your prototype. All right. So that's your build documentation. You want to have your final prototype here at the end, and then go through your testing. So here, briefly state your testing requirements. So this is a summary of your test procedure and then what you're going to be looking at. So here we have current and power. We have some sample calculations here. We've got a diagram of how it would be tested, and then just a kind of an overview of how to test it. The procedure is very thin, and I know I've asked you guys to do very detailed ones. That would be if for your final documentation as an appendix, you would have here's how to test current and power, but for your presentation, you just need to specify what it is, show some sample calculations, and you need to be able to, from this slide, tell how you tested it, and that's what you would focus on here, how you're going to test it. So we looked at current and power, we looked at gear ratio and output torque, and you can see that same format. Notice I've got the data collection format and then some calculations here. And then this one we have some graphs and stuff that we actually put together. This is feed rate and being able to explain how we, using this diagram, it's helpful. You can explain how you tested your prototype. Looking at your physical properties, one of the things that we wanted to be sure we understood and could communicate was our center of gravity to show that it would be difficult to tip our design over. We also had the hopper capacity, how much it could hold. So we had some calculations for finding the volume of our container here. And then we also had a test for accessibility, and we actually put it in the field with actual chickens, showing this picture right here. You can see that they can very conveniently eat from it, but it's not easy for them to get into and try to scratch in it. And that was one of the keys to our design. So our results, we summarize these a little bit. A better way to do this would be to show graphs, like bar graphs, pie charts, comparisons of a control versus your model. Do this visually. We just kind of went through this talking about the results. It's going to be better to break this down into individual slides and have something visual that you can discuss. Okay. For our conclusions, we talked about the wrap up of the project, the things that we were able to do successfully, the things that we talked about that were a possibility, and things that we almost hit. So we kind of reviewed our process specifications that we said our design would be able to do, and kind of went through the parts that went well and the parts that didn't go well. Okay. Second part of the conclusions is looking forward. If you were going to make a second iteration, or if someone were going to pick up your project, what would they need to incorporate in a second version of this design? For instance, we said it needed to be adjustable for the tray height. It needed to be weather and rodent resistant. We needed to make sure it was easy to fill and clean. We need and have evidence that shows that it was. Make sure that no moisture could get into the hopper and contact the feed, and make sure that the chickens could not just perch on top of it, and also making it goat proof, which was from our survey. Okay. Recommendations, things that we would have done differently or could done better. So including more research, we would have gone through our parameters a little more carefully before getting user feedback, and then we would have spent a bit more time thinking about the solution design and how we plan to construct it, so that our final and our plan and our actual prototype were more closely matched. Because if you look at what we showed in our drawings and what we actually built, there were some pretty significant variations. For the thank you slide, you need to list everybody that contributed to your project, or recognize them and say specifically thank you, especially if they're with you. So in this case, we had our teachers, the person who was over the makerspace we were using, the Facebook groups that we got support from, the family farm that allowed us to test our prototype there, and to the venue staff for making sure we had snacks and drinks so that we could work efficiently. So anybody that had any contribution, especially if an expert has given you input, you need to make sure that's in here. And then finally, questions. So you want to have a little bit of time here at the end for your question session. Okay, so that really what I want you to do is try to shoot for 17 minutes, and that way you've got about 3 minutes to answer a few questions, but not more than that. Let me remind you, if you rip through this presentation and finish it in 10 minutes, I'm going to leave you up there to answer questions for 10 minutes. And I will start providing people questions if you, so yeah, try to use up most of your time, but leave a couple of minutes at the end so that you can answer some questions. All right. And that's the end of this part.